Hello students, welcome everyone to the second topic, that is chemical kinetics of this revision series. So first I'll write the topics which I am going to discuss in this series. First topic is rate of chemical reaction. We write this to be a rate of chemical reaction. Rate of chemical reaction. Right, this is the first thing. Second, we are going to here we are going to write a rate expression. In this we can understand rate expression and rate law. Right. Second, order and molecularity. Okay. Then integrated rate equation. Then there is a integrated rate equation, and fourth is temperature dependency. Temperature dependence of the rate of reaction. Basically, in this last topic, we discuss about this Arrhenius theory. Okay, Arrhenius theory for the Arrhenius equation we learn. Arrhenius equation. Like Arrhenius equation tells about a temperature dependency. K is equal to A e raised to minus EA by RT. This is that equation. Whole our study will be based on this equation. So let's start rate of chemical equation. So what is the rate of chemical equation to start with? Since this is a revision, I'm expecting that you are knowing some. I'm assuming that you know some concepts already. So rate of chemical reaction. Right? Rate of reaction is what? Let's say there is a reactant A, B, C, D. A, B is the reactant, and let's say this is C and D are the product. I'll put some stoichiometric coefficient over here. So rate of reaction could be expressed in terms of decrease in concentration of any one of the reactant or increase in concentration of any one of the product. Means we can write this rate of reaction is decrease in concentration of any, or we'll write it together, decrease, or to make it short, change in concentration. We'll write change in concentration of reactant or product. Any one of the product, reactant, any one of the reactant or any one of the product upon time. This is short and sweet definition. Now, to do this, let's say you want to write a rate for this. You can write rate is equal to concentration of the reactant. A is there. So how you will write? You will write this to be minus delta A. I am considering the average rate only, and this is by delta T. Minus I have written. I can also write rate is equal to, I can write rate is equal to minus here 1 by 2. It is stoichiometric coefficient will come down, or we'll write it this way. Minus 1 by 2. Here it is minus 1 by 3 delta B by delta T. Significance of minus I'll tell you. And then this is also could be written, rate could be also written increase in concentration, means 1 by 2 delta C. Square bracket represents concentration delta T. Also it could be also written rate to be is equal to 1 by 2. 1 by 1 doesn't matter. So we'll write delta D by delta T. Like it could be written continuously like this. Don't get confused. It is one and same. Rate could be expressed in so many ways. Right? Now what is the meaning of this minus sign over here? Means rate, speed cannot be negative, but minus sign is there. What does that mean? So is it minus? Is it really a minus? No, it is not minus. It is positive, because this delta A is negative, this difference is negative, like value is negative, and this negative makes it positive. Like for example, I'll consider time t is equal to 0, initial concentration. Then let's say the concentration of the A is maximum. How much? Let's say the concentration is 10 over here. This is also 10. This is 0 and this is 0. Let's say after 10 minutes, what happens is that obviously what would be the concentration of A? Certainly that concentration won't be is equal to or equal to or more than 10. This concentration won't be more than 10. After 10 minutes, certain reactant is getting consumed. So let's write that concentration has become after 10 minutes to be 4, and this is also 4. And let's say here it has increased by 6. Now, when you write after 10 minutes, what is the rate? What is the rate? You will write minus delta A by 2 and delta T. What is this minus? This is what delta concentration difference in a concentration of A. It is what? Final, I'll write a concentration of A. Then delta I am replacing. Concentration of A final minus concentration of A initial divided by delta T, and 2 is also there, no? In this case there is 2, right? So this minus 1 by 2. What is final over here? What is final? Final is 4, right? After 10. What was initial? Initial was 10. And what is this delta T? This is also 10 minutes, after 10 minutes. So what is this? Minus 1 by 2. And what is this? Minus 6 by 10. So minus and minus becomes positive. 6 by 20. Positive. So rate is positive. So this difference is negative. That's why this minus sign is there. So together it becomes positive. Right? If you write for a product, let's say I am considering this in terms of the product. So rate is equal to 1 by 2 delta C by delta T. So 1 by 2, what is that? Delta C. Concentration of the C final minus concentration of C initial upon delta T. So 1 by 2. Why minus sign is not there? Let's check. Final is how much? 6. And what is initial? 0. And what is the time? 10. So 1 by 2 into 6 upon 10. This is also positive. 6 by 20. Getting? So this is what the significance of the minus sign into the rate expression. Let's take one question. Here is a question. Nice question. You can give a try. Very simple question. Right. For the reaction, this is the reaction which is given. Rate of formation of NO2 is given and is 2.8 into 10 to minus 3 moles per liter. That is molarity per second. Calculate the rate of disappearance of N2O5. Okay, so this is asked. So how do we write a rate for this? Rate could be also written as minus 1 by 2 delta N2O5 by delta T, which is equal to 1 by 4. Since this is a product, I am not putting minus sign. Change in concentration of NO2 by delta T, which is also is equal to, rate can be also written this way, 1 by 2 delta change in concentration of O2 by delta T. Right? So that is what, no? Right? Rate could be expressed in decrease in concentration of any one of the reactant or increase in concentration in any one of the product. It could be expressed this way. Now rate of formation of NO2 is given. What is given? Rate of formation of NO2. So somewhere we have this data, So I'll equate it with this. So rate, what you are told to find? Calculate rate of disappearance of N2O5. So we'll equate this because about NO2 is given, and you are told to find N2O5. So I'll equate these two things, right? So what I can write, minus 1 by 2 delta N2O5. See, you should be very much careful in identifying what is the meaning of rate of disappearance, rate of formation, and what is the rate of reaction from the equation. You should be able to differentiate that mathematically, right? This rate of formation is different from a rate of reaction. Okay, so I'll just equate this first and then I'll explain you what is this 1 by 4 delta NO2 by delta T. You see this, I have divided this stoichiometric coefficients of this. Like without this part, what is this? This a bracketed term, okay, round brackets which is there. This represents what? Rate of formation and not a rate of reaction. Rate of formation of NO2. And with this 1 by 4, what it will become? Rate of reaction. If you include this 1 by 4, it will be a rate of reaction. Understand? Right? Here, in this side, what is asked? Rate of disappearance of NO2. I will write this same form as minus delta N2O5, change in concentration, and delta NT, which is equal to 1 by 4 by delta T. Hope this is coming into the frame. Yeah, good. So what is this term, this bracketed term? I have taken that minus sign inside. So including, you know, that minus, and this is what? Positive. This is what? This is rate of disappearance. Rate of, this bracketed term is rate of disappearance of what? N2O5. So this bracketed term I am writing minus, this is what is asked, minus delta N2O5 by delta T, which is equal to, when this will go over here, this will be 2 by 4, and what is this value? This value is given, rate of formation of NO2 or rate of appearance of NO2 is given to be 2.8 into 10 raised to 3. This is the unit which is given. Now what is this unit also? Unit is what? Capital M stands for moles per liter and this per second. This is a unit of what? Unit of the rate of reaction. So this capital M is a molarity, moles per liter. So this is 1 by 2, so 2, 1, 4. So answer is 1.4 into 10 raised to minus 3 molarity per second. Molarity means also it could be written 10 raised to minus 3 moles per liter per second. Right? So units of rate of reaction will be, what would be units of rate of reaction? It is written moles per liter per second. It is always moles per liter per second, unit of rate of reaction. Right? So how rate is equal to, understand, huh? Many students get confused. Units of rate and the units of rate constant. Unit of rate constant is variable for the first order, second order, third order, half order, fractional order. The unit of rate constant is changing with respect to order, but units of rate is going to remain same, whether it is zero order, first order, or any order. So rate is equal to what? Change in concentration. Change in concentration upon time. Right? So change in concentration, it is a concentration, unit will be of what? Moles per liter. Time is what? Second. So unit is what? Moles per liter per second. Fine. Okay, many students ask me what to do with this minus sign. Okay, I want to tell this. What about this minus sign? Will it not come over here? No, because with this minus sign and with this term, that is what the quantity rate of appearance, rate of disappearance, right? So don't worry about this minus sign. Together, rate of disappearance means what? Mathematically it is minus delta and change in concentration of N2O5 by delta T. That is the thing. Hello students. Here, next topic of the revision is order and molecularity. So to understand order and molecularity, first we need to know what is a rate law expression. See, first we'll write a rate law expression. Rate law expression. So here, we say that rate is directly proportional to the concentration of the reactant. Rate is directly proportional to the concentration of the reactant. Means rate is directly proportional to the concentration of reactant. More is the concentration of the reactant, more will be the speed of the reaction. Like let's say there is a reaction 2A plus 3B giving you 2C plus 4D. These are the thing. Okay. Now what we'll write is that I'll just write this stoichiometric coefficient as the small a, small b, small c, and this small letters are stoichiometric coefficient. So for this, rate will be written as directly proportional to concentration of A raised to x and B raised to y. Now why x and 1? Why not A and B? See, this would be true, like x and y. I would have written A is A raised to small a and B raised to small b, provided this reaction is one-step reaction. But we don't know whether given reaction is one-step reaction or it is taking place in many steps, right? That could be understood experimentally, or it should be at least told. It should be told to you that okay, this reaction is one-step reaction. That time you can write. There are two kinds of reaction which takes place in one step, and there are reactions which takes place in a more than one step, right? So that's why I have not written this is equal to A and B. So rate is equal to K, A raised to x and B raised to y. What is this K? K is a proportionality constant called as a rate constant over here. Now coming to the concept order. Order is what? Order is sum of the powers to which concentration terms are raised in rate law expression. So what is the order over here? Order is x plus y. This is what the order. Now what is the molecularity? Molecularity, I'll write the definition of the molecularity over here. Molecularity is what? It is, see, for a reaction to happen, what should happen? A collision between a molecule should happen, or a collision between the particles should happen, right? You just imagine, you're just walking in a corridor, right? And you collide with someone. You will show some reaction, like this is sorry, or you will show anger, something, right? Without collision with some other person, you're not going to show reaction. For the reaction, what is important? Collision is important. Same is true with the molecules also. Molecules, when they collide, and there will be a reaction. So molecularity means what? Number of molecules which collide simultaneously to bring about chemical reaction. So that is what the molecularity is. I'll take this concept, order and molecularity together, then we'll solve some problems. Okay, I'll write one reaction. The reaction is this. Reaction is given this way. 2NO2, this is the reaction. This is a gas. This is fluorine. This is also gas. And on reaction, this gives you 2NO2F. This is gas. Now rate law expression for this. What do we expect a rate law expression? You cannot write a rate law expression unless and until it is mentioned, okay, this is one-step reaction. If it is a one-step reaction, then you will write rate is equal to K, concentration of NO2 raised to 2 and concentration of F2 raised to 1. Right? But it is not a one-step reaction. This is in reality not one-step reaction. It takes place in several steps. That's why I cannot write this. But experimentally the data is provided, reaction is done. Experimentally, it is said that rate law expression for this is given to be K, NO2 and just F. This is what the rate law is given for this. What is the reason for this? That this is what the rate law, why that is 2 is not there over here, because this reaction takes place in a 2 step. Now we'll write the steps. So step 1 of the reaction, is that one NO2 molecule reacts with a F2 to give what? NO2, F and F. Like this is step 1 of the reaction, and this step is a slow step. Okay, slow step is also called as a rate determining step, right? And this is step 2. What is step 2? You write this NO2 F, which is formed. Okay, new molecule NO2 react with F, and this gives you NO2F. So this is second step, and this is fast step. So what is the overall reaction? Overall reaction, you should be getting this. Let's write NO2 and NO2, 2 times NO2, F2, right? This F and this F, same species on the opposite side of the arrows in 2 reactions, are going to get cancelled, right? So this will give you 2 NO2F. Yeah, you are getting this. But over here, for a complex reaction, this is a complex reaction. Why I am saying that it is a complex reaction? Because it is taking place in more than one step. For a complex reaction, rate law is always written for slower step. Rate law is always written for the slower step. Now, which is a slower step? This is what your slower step, right? So for this, isn't it a stoichiometric coefficients are equal 1 and 1, first step. If this was slow, then this is F2. Over here it is F2, right? So if this was slow, NO2 and F it would have been. But since this is slow, I am writing a rate law expression for him. That is what the rate law expression for this reaction, for the slower step. Because slow step is the rate determining step. Because slow step will decide what is the rate of the reaction. Getting? This is what the order is. Now molecularity. Now molecularity over here is what? Molecularity has a meaning for a one-step reaction. For a complex reaction, like if the reaction is taking place in a 2-step, over here molecularity is what? One molecule is colliding with another molecule. So over here molecularity is 2. Over here one particle and one atom is one molecule and one particle is colliding. So it is again molecularity is what? Molecularity is 2. But we cannot say that total molecularity is this and this. Like sum of this 2 and 2 means molecularity for this molecule, for this reaction is 4. For a complex reaction, saying molecularity has no meaning. We define molecularity only for the simple steps. There is no overall molecularity. Okay, maximum molecularity so far obtained, I guess it is 3 or 4. Maximum is 4, right? And molecularity. Okay, we'll talk about the differences between an order and a molecularity. We'll talk about the differences in an order and molecularity. So this is clear, molecularity and the order. So order and a molecularity. If I want to write an order and molecularity, difference is what? Okay, order is what? Like you can write a definition, sum of the powers to which concentration terms are raised in a chemical rate law expression. Molecularity is what? The molecules which collide simultaneously to bring about a chemical reaction. That is what the molecularity. The major difference over here is that order may be 0, this may be 0, it could be fraction also, it could be a fraction also, 1 by 2, 1 by 3, okay, it could be fraction also, or it can be negative also, But molecularity is what? Molecularity is always whole number. Molecularity is always whole number. 1, 2, 3. That is what the molecularity. We cannot say like half of the molecule is coming and colliding. 1.25 molecule getting colliding. No, it is either full or no collision. One molecule is coming and colliding with the other, another one, right? It is full molecule, half molecule cannot collide. You know, when you walk in a corridor, you're colliding with someone. You are one person and another full person, right? Colliding. It cannot be like you are half colliding with another full person and the molecularity is 1.5. No, that's not possible. So it is always full you have to consider. So it is always 1, 2, 3, 4, 5 like this. Let's discuss about the unit of the rate constant also. Units of rate constant for 0, first, second order, right? Or a different order, right? So unit means what? How do we write? Rate is equal to K and concentration of reactant raised to some n value. Okay, n is the order, right? So for first order reaction or for zero order reaction, you will write this K is equal to rate upon R raised to n. So rate unit is what? Moles per liter per second. What is the unit of concentration? Moles per liter raised to what? 0. Anything raised to 0 is what? 1. So moles per liter per second. So this is unit of rate constant for the zero order reaction. For the first order reaction, we'll write this K is equal to what? After rearranging, K is equal to rate upon R raised to n. For the first order reaction, whether it is the first order, second order, units of the rate is always constant. This is going to vary. So it is moles per liter per second, and this is what? Moles per liter raised to 1. Means this quantity and this quantity. The unit is what? Per second. Right? So for this was for a first order. I forgot to write over here. This is first order. Then what? A second order. You can consider a second order also. Second order. Second order is what? K is equal to rate and concentration of the reactant raised to 2 I am putting directly. So rate is what? Moles per liter per second. What is concentration? Moles per liter raised to 2, because raised to 2 is the second order is there. So what is this? Mole per liter per second, moles square liter raised to minus 2. So if you do this, this will become what? Per mole when it goes on the top, per mole. This will become liter, because this will become liter raised to 2, no? And this is minus 1. So liter raised to 1 per second. So this is the order. This is how you can remember the units of the rate constant for first, zero, first and second and third order, and any number of them. But remember, unit of the rate is always same. That is moles per liter per second. Unit of rate constant is going to get vary. The question, there was one simple question was asked. Okay, this is the question. Very simple. I know how to solve this. Identify the reaction order from the following rate constant. Rate constant value is given. How will I identify? From the units. So that is the simplest way to identify the what is the order of the reaction. So here unit is given is what? Liter per mole per second, or per mole liter per second is one and same. So this is what? This is unit of the rate constant when the order is second. This is second order reaction. If this was per second, then it is first order, right? If it is moles per liter per second, then it is what? Zero order. Isn't it? Very simple. Here is a question for the reaction H2 and a chlorine gas reacts to give 2 moles of HCl, and this is what the rate law expression. They have given the rate law expression to be rate is equal to just K. Write the order of reaction, order and the molecularity of this reaction, and write the units of K. See, write the order and molecularity. So I'll mention about this. This is a one-step reaction. This is one-step reaction, elementary reaction. Okay, one step reaction. Unless and until it is mentioned, you cannot do this question with respect to molecularity. If it was a complex reaction, they should have at least given 2 steps in which the reaction is proceeding, 2 or 3 steps, and they should mention that this is a slower step. Then also you can calculate the molecularity for that particular reaction or particular step. Question is order of the reaction. See, they have written rate law to be K, rate to be is equal to, solving first one, rate is equal to just K, means what? Concentration of the reactant, like concentration of H2 and concentration of Cl2, both are what? 0. This is what the actual rate law. When this both are 0 means what? Anything raised to 0 is what? 1, and this is also 1. So therefore, rate is what? Is equal to K. You will get this only when the concentration when the order is 0. So order for the first one is 0. And what is the molecularity? Since it is a one-step reaction, this is 1 and this is 1. And the molecularity is what? This is order, which is equal to 0. And molecularity is what? Molecularity is 2. Write the units of the K. For the zero order reaction, rate is equal to what? K, concentration of reactant raised to 0. Unit is what? Rate upon concentration of reactant raised to 0. Anything raised to 0 is 1, but still I write units of the rate is moles per liter per second, and this is what? Moles, concentration of the reactant is moles per liter raised to 0. So K is equal to what? Moles per liter per second. Answer is, units of the K is moles per liter per second. Now this is a good question. A reaction is first order in reactant A and second order in reactant B. How is the rate of this reaction is affected when concentration of B alone is increased to 3 times and concentration of A as well as B are doubled? So first we'll write a rate law expression for this. Rate law expression for this could be written this way. Rate is equal to K. Reactants are what? A. It is second order, no, first order with respect to A and second order with respect to B. Okay, this is certain concentration. I will write this is to be rate 1. Rate 1. So obviously when you change the concentration of A and you change the concentration of B, rate will be different. So I'll write when I change the concentration, we'll solve this first one. Concentration of B alone is increased to 3 times, means you will have new rate, I'll write rate 2. Concentration of the A is same, concentration of B is become what? 3 times B. So now this is the new rate. It will be different from this, the earlier one. Let's say here the rate of reaction is 10, like 10 moles per liter per second. Right here, since you have increased, it may become something 50 moles per liter per second. 3 times you have increased. Just give me an example. It will be more than that. So here, what would be this rate to new rate which is there? Speed of the reaction. K, A, what is this? B raised to 2, and this is what? 3 square, no? 3 square. So what is this? 3 square is 9. I will write this first, 9. And this K, A, B raised to 2. So this is rate 2. Rate 2. So rate 2 is what? 9 into what is this? KAB square. KAB square equals rate 1. So it is, rate is becoming 9 times of the rate 1. Concentration of A as well as B are doubled. Means now rate 3 I will write. New rate, which is different from a rate 2. When concentration of A and both B are doubled. So what would be this? I'll take this 2 outside. K, concentration of A. I'll also take this 2 square. Okay, we'll write it independently. K, 2, concentration of A. 2 square into concentration of B, the whole square. K, 2, A. 2 raised to 2 is 4. So this is 4 into 2 is what? 8. K, A, B the whole square. So rate 3 is what? Rate 3. Rate 3 is 8 times what is this? Rate 1. right? First it is increasing 8 times and the earlier it was 9 times. Okay, this question, for an elementary reaction, reactant M changing to product M, the rate of disappearance of M increases by a factor of 8 upon doubling the concentration of M. The order, okay, this question is the order of reaction. Main thing is only missing out. The order of the reaction is, order of the reaction. Okay, well, I'll write this. The order of reaction is dash. So they have mentioned rate of disappearance of M. See, in this case, rate of disappearance will be equal to rate of reaction because over here stoichiometric coefficient is 1. If that is not 1, that time rate of disappearance is not is equal to rate of reaction. So how do we write? Rate is equal to K M raised to X. I am putting this is equal to this. This is my equation 1. What they are saying is that when you double the concentration, upon doubling the concentration of the M, it becomes 8 times. Let's say this is rate 1. So this will become 8 times. Rate will be 8 times to that of the rate 1 when you double the concentration to M raised to X. I don't know this order with respect to M. Right? So dividing equation 1 and 2, dividing you do 2 by 1, 1 by 2, doesn't matter in this case, don't worry about it. Oh, what I need to do, I have to divide 1 by 2 or 2 by 1. Okay, doesn't matter. You can do 2 by 1 or 1 by 2, dividing equation 1 by equation 2. Means what I write over here, I write rate is equal to rate by 8 times rate 1 upon 8 times rate 1 is equal to K M raised to X, and this is what? K 2 M raised to X. This K and this K will get cancelled. So what is this? 8. I can write this, since power is same, I will write this M upon 2M raised to X. This M and this M is getting cancelled. 1 by 8, 1 by 2 raised to X. Right? So can I write it this way? Can I write it this way? Like 1 by 8. 1 raised to X or anything raised to X is what? 1. Sorry, not anything raised to X. I mean, anything raised to 1 is what? 1 only. 1 raised to 2, 1 raised to 5. So this is what? 1 by 8 is equal to 1 by 2 raised to X. Therefore, 2 raised to X is equal to what? 8. Can I write 8 as 2 raised to 3? I can write, no? So if you take log on both sides, what do you get? Directly you can say X is equal to 3, but just telling you how to do this, how X is equal to 3. If I take log on both sides, I can write log of 2 raised to X is equal to log of 2 raised to 3. Using identities of the logarithm, this could be written as X log of 2 and 3 log of 2. This and this will get cancelled. So X is equal to 3. So what is the order for this reaction? Order is 3. Right? Answer is 3. Hello students. Here in this lecture, we are going to learn about the integrated rate equation. So I'll write the heading. Integrated rate equation. So there are two integrated rate law equations for you. Like first is first order for first order reaction, and other is for zero order reaction. So these equations are this way. For the first order, it is ln of r is equal to minus kt plus ln of r0. Okay, and for the zero order, it is r is equal to minus kt plus r0. Now what is this r and r0? See, in this case and that case, r is what? It is a concentration of reactant at any time. It may be at this time, let's say after 1 minute, after 2 minutes, after 3 minutes. That is what it means. And r0 is what? R0 is the maximum concentration or the initial concentration of the reactant, right? If we relate this with the equation of straight line, right, I'll write this: y is equal to mx and this is c, right? This is on a y-axis, this is here m variable, along x-axis is the t and slope is minus k, right? And this is the intercept. If you want to draw a graph of this, the graph will be this way. This is the time, this is how the time varies, and this on this axis it is ln of r. Maximum value of ln of r is this. This will be ln of r0, this value, and the graph will fall this way. So from here to here, or we can say this distance, this is the intercept. This is the intercept, right? C means what? Intercept. Intercept, right? And what is the slope over here? Slope of this graph, which remains constant. Slope is equal to minus k. Over here, again, the graph is this way. Here it is variation of r and against t, and this is the thing, this is how the graph will fall, and this is a slope which is equal to minus k. Maximum value of the concentration of the reactant is r0. This is intercept, or this is the r0, that is what we say. Like this is the initial concentration of the reactant, right? So there are two graphs which we are having. Now both reactions will have half-life. What is the meaning of half-life? Half-life, a time at which it is a time at which concentration of reactant is half of its initial concentration. Okay, if you solve that for this equation, what you are going to get is T half is equal to 0.693 upon k. Okay, that is what T half you are going to get. And over here, T half will be is equal to R0 by 2k. Right? These are the equations which you should remember. Now, let us solve some questions based on these equations and the concept. Okay, this is the question. A first order reaction takes 40 minutes for 30% decomposition. Calculate T half for this reaction, means half-life you need to find. So what is the formula for a T half? T half formula is this: 0.693 upon k. Means you want from this data we need to obtain what is k, that is rate constant. See, what is the integrated rate law expression we are having? We are having this ln of r is equal to minus kt plus ln of r0, right? R is what? It is the concentration of the reactant at time t. Means with time this concentration of the reactant will be less than the initial concentration. This R0 is the concentration at a zero time. That is the initial concentration or maximum concentration of the reactant. Now how to get a K, how to write for this? Like I'll write this KT is equal to, I'll write KT is equal to ln of R0 minus ln of R. So here KT is equal to, we can write this is equal to by identities of the logarithm we can write this way, isn't it? So what is K is equal to? K is equal to 1 by T ln of R0 by r. Now when we convert natural logarithm to logs, we multiply 2.303 this factor and log of r0 and r. Okay, usually what is expected from you is that you should remember this formula directly. You don't sit deriving in an exam, it will consume a lot of time, but if at all if you are forgetting, then you can derive this. So we started from here. So here we can get the k. Using this data we can get the k. So first to find k, so to find k, I need to substitute over here. So what we have initial concentration, it is not given. What is said is 30% for the 30% decomposition. Let's say initial is 100, okay, and 30% is decomposed, means how much is remaining after 40 minutes. 30% is decomposed means how much is remaining? 100 minus 30, that is 70%, or we'll consider 70%. Right? We'll not write this percent sign. Okay, this is the concentration. If this is 100, after 40 minutes, a 70 is remaining. So what is k is equal to? What would be a k is equal to? And how much is the time? Time is given to be 40 minutes. Okay, therefore k is equal to I need to substitute value of k over here, then I will get t half. So k is equal to how much? 2.303 upon time is 40 minutes, and this is log of initial I had taken 100 and 30% of its decomposing means 70 is remaining. So this will be a thing. So k is equal to 2.303 divided by 40 and log of 1.4 something, right? So value finally we can write this is equal to 2.303 upon 40 into log of 0.1548. Okay, after multiplying all these things, k value I am getting, k value after solving this, I'll write the value, it is 0.00891 per minute. This will be the unit of the rate constant. You know that the unit of the rate constant for a first order reaction is per minute, and you can also see over here that the units of this and this gets cancelled, remains is only of this. This was a minute, when it comes on the top it becomes per minute, right? Therefore t half is what? 0.693 upon 0.00891, and finally t half value you are getting is 77.76 minutes. This is a t half value which you will be getting for this. Okay, this question is also based on a first order reaction. Question asked is first order reaction takes 20 minutes for 25% decomposition. Calculate the time when 75% of the reaction will be completed. Like formula what you will be using for the time is this, t is equal to 2.303, same formula. Only thing we take t over here, k over here. Like if I want to find a rate constant, I'll take k over here and then find t. And this is log of r0, means concentration of the reactant at 0 time, and this is concentration of the reactant at time t, right? This is what the formula is. Now calculate the time when 75% of the reaction. See, to find a 75% completion of the reaction means, you know, this is 100 and 75% complete means what will be remaining over here? Just 25 is remaining, right? So to do that I need a k, right? There is a data given initially that first order reaction is 25, takes 20 minutes for 25% completion. Using this data I can find a k. See, k is something which is never going to change with change in concentration. Whatever may be the concentrations for the particular reactant, change in concentration, that is not going to change. K changes only with temperature. If you change the temperature, its rate constant is going to change. Okay, so over here first we'll find the k for this. So I'll rearrange this. To find k, k will be is equal to what? 2.303 upon time into log of r0 by r. Using this set of data, right, we'll find k. So k is equal to what? 2.303 and a time is how much? 20 minutes, 20 minutes. And what is the concentration given? What is the concentration, initial concentration? They did not give anything. They said that 25% decompose means 25% of the reaction has taken place, means how much is remaining? 75%. So initial concentration, if you are considering, then you should be considering this should be 100. This is the simplest way to do this. And 25% is decompose, means what? 75 is remaining. You know, this question could be asked in a different way also. Like, you should be taking care, you know, it may be asked for a 25% decomposition. It takes 20 minutes for 25% decomposition. Or the question may be also this way. A first order reaction takes 20 minutes for reducing its concentration to 25%. To 25% means what? Reducing its concentration to 25% means it was initial 100, it is changing to 25%. In that case, you are not going to do 100 minus 25. You are writing that 25 as it is, as a concentration of the reactant at time t. Okay, understand this difference of the language. So this would be what? Therefore, K will be is equal to what? 2.303 upon 20. And what is this? This will be 25 4 times, 23 4 times. So this is log of 4 by 3. How to find log of 4 by 3? You know, logarithm table will be provided in your exams, yes, but still without logarithm table we can do this. So this log of 4 by 3 could be written as log of 4 minus log of 3. So this is 2.303. Log of 4 is how much? Log of 4 is how much? We don't know the log of 4, but we know log of 2. Always remember these values. Log of 2 is 0.3040. Right? And log of 3 is how much? Log of 3 is 0.4771. This is log of 3. Okay, this is log of 3, 0.4771. This is 0.3010, not 40. Right? These values you should do. So what I do? Log of 2. This could be written, 4 could be written as 2 raised to 2. So what I'll do, I'll solve this separately, otherwise I will have to write this again and again. So how to solve log of 4? Log of 4 could be written as log of 2 raised to 2. So what is this? This could be using logarithmic identities, could be written as log of 2 into log of 2. So 2 into log of 2 is what? 0.3010, which is equal to 0.6020. So here I am writing 0.6020 minus log of 3 is what? 0.4771. Now you can solve this easily. Finally, I'll write a K value. Final answer for the K is coming to be 0.0143. 0.0143 per minute. Now you got this K value. Now substitute that K value for this data. Then you will get a time, you know, time when, here you are told to find K, here told to find time, right? So I'm substituting that time over here. Substituting that K over here to find a time. So time is equal to what? Earlier we found out K using same formula. I am finding K log of R0 by R. So this is what? 2.303, and K I am getting 0.0143 per minute, means the unit will be later minute of this time. So log of R0 is 100 I am considering, and when calculate a time when 75% of the reaction is completed. 75% of reaction is completed means what? 25 is remaining, right? So 100 minus 75, no, this will be 100 minus 75, which will be is equal to 25, right? So this is 4. So this is 2.303 upon 0.0143 into log of 4 will be what? Log of 4 is 0.6020. the final answer for the time. Therefore, time is equal to, the answer comes to equal to 96.96 minutes. Okay, these are the questions you can handle this way. Okay, this question, the graph is given and they have mentioned about the slope. Slope is equal to minus 6 by 6.909. Okay, what will be the value of rate constant? That is what is asked. See, if you carefully look at this, this is equation of this. No, this graph is the equation behind this graph is this, minus kt upon 2.303 plus ln of plus log of r0, right? This is what the equation is. How we are getting this equation? See, we know a equation for this ln of r is equal to minus kt plus ln of r0. We know this. So when we convert this value 2.303 natural logarithm to log, we write it this way: log of r minus kt plus 2.303 log of r0. Now dividing equation throughout by 2.303. Now I divide this equation throughout by 2.303. So 2.303 log of r and 2.303 minus kt upon 2.303 plus 2.303 log of r0. What do you get? What do you get? This get cancelled. You get this equation. You get this equation. So this graph is for this equation. So what is the slope over here? What is the slope over here? Slope is equal to minus k by 2.303. And they have told you to find the value of k. So let's find the value of k. Since we have the value of the slope, we can easily find the value of the k. So slope is equal to what? Slope is equal to minus 6.6909. Right? What is slope of this graph? Slope of this graph is this. So minus k upon 2.303 is equal to minus 6 upon 6.909. Right? So k will be equal to what? This and this will become positive. So this is k will be equal to 60909 and this is 2.303. This will cancel 3 times and this 3 2s are. So k will be equal to 2. Right? Since it is first order reaction, unit will be per minute or per second. We'll consider this to be a per minute. Okay, or a unit will be per time, we'll write. Per unit will be time inverse. Right? Next topic which I am going to discuss over here is a pseudo first order reaction. Pseudo first order reaction. See, when this happens, let's say there are 2 reactants. Basically, what is the order? Order is, we'll write this, rate is equal to K. And let's say there are 2 reactants, A and B. Let's say this is first order, this is also first order, right? What is the order of this reaction? The order of this reaction will be is equal to 1 plus 1, which is equal to 2, right? So over here, what is the meaning of pseudo first order reaction? It looks like it is a second order reaction, but it will follow a lower order kinetics, that is first order kinetics. When it happens, when do we get a pseudo first order reaction? When this is possible? When one of the reactant is present in large excess. Okay, like for example, if you take ester like this, what we say a hydrolysis of the ester, hydrolysis of the ester, that is ethyl acetate, and hydrolysis means we will require water. let's say this is 10 mole, this is 10 mole you are taking, and this is something 0.01 mole, this is 0.01 mole. After hydrolysis in the presence of acid, what do you get? You get a carboxylic acid CH3COOH and alcohol C2H5OH. Now don't worry about the reactant, but while taking a reaction, while doing a reaction, reactant at time t is equal to 0 is this concentration of the reactant is 0.01 and this is 10 mole. You can see that this is very large value than this, right? And this is 0 and this is 0 because reaction is not started at, let's say after, let's say this reaction takes 10 minutes for the completion, or let's say 15 minutes for the completion. Let's say after 15 minutes, what will happen is that since this is a limiting reagent, this is present in a less amount, right? So this will be getting completely consumed, means over here this is 0.01 will be getting completely consumed. What would be this? This will be 9.9 mole which will be remaining. This is 9.9 mole which will be remaining, right? So yes, I should consider this to be 0.1 mole. Okay, I'll consider this to be 0.1 mole, and this is 9.9 mole will be remaining over here. You see that how much will be getting? 0.1 mole of this, 0.1 mole of this. But you see that this is 9.9 mole and this is 10 mole initially. So 9.9 is very close to 10, means there is hardly any change in a concentration of the water. Means while writing a rate law expression for this, what we will be writing is that rate is equal to K CH3 COO, that is ethyl acetate, and concentration of the water. So this is constant. So what we can see is that in this reaction, this is first order, this is also first order. The concentration of the water is not changing. It is almost constant. That is from 10, it is changing just to 9.9. So what I'll consider is that I'll write this K H2O. I'll just write this CH3 COO C2H5. This is rate. So rate is equal to what I consider K dash. K dash means what? This is also constant and this water concentration is also constant. Together I call this to be a K dash, and over here this is what the equation you are going to get. Means what? This is, although it looks like a second order, but it just follows a first order kinetic. That is a meaning of the pseudo first order reaction. There are more examples. Inversion of the cane sugar is also an example of the pseudo first order reaction. It looks like a second order, but it follows a first order reaction since one of the reactant is present in very large excess. Next topic is temperature dependence of a rate of reaction. Okay, temperature dependence of rate of reaction. Remember, the value of rate constant increases, the rate of reaction increases. Okay, the one which is having higher value of rate constant, for that rate of reaction will be higher. Like it is given by the Arrhenius equation. We know this equation. Since we are revising, we know this Arrhenius equation. What is that? K is equal to A e raised to minus EA by RT. Now what is A? K? K is a rate constant. K is rate constant. K is rate constant. A is what? A is Arrhenius parameter. Arrhenius parameter. Now what is this Arrhenius parameter? What is the actual meaning of this? Actual meaning of this is that it is a maximum value of the rate constant that is possible. Okay, obviously if T is very high, this will be what? E raised to 0. If T is very high, then E raised to 0, anything raised to 0 is what? 1. So K will be is equal to A. So Arrhenius parameter is that value of the rate constant at very high temperature, right? So this is the thing. EA is what? EA is activation energy. It is activation energy. Activation energy is something which is again constant. It can be varied. Activation energy can be varied, only by using catalyst. Temperature does not alter activation energy. T is what? Temperature. Right? So it is said that for every 10-degree rise in temperature, what happens? The rate of reaction become always double. Means we can say that rate constant doubles. Why? What is the reason? See, there is a container. When does the reaction takes place? Let's say these are the particles which are there in a container. Let's say two kinds of particle. There are two kinds of particle. All these particles, when they are going to collide one another, what will happen is that there will be reaction between them. So what is important for the reaction? Is a collision between the particle. So when we increase the temperature, the degree of the randomness, or what we can say is the entropy of the particle increases. So the number of collision increases and the rate of reaction increases, right? For every 10 degree, it is said that for every 10 degree rise in temperature, the rate constant or rate of reaction always doubles. Let's take one problem for this. So a question is, rate of reaction becomes double when temperature is raised from 298 Kelvin to 308 Kelvin. This is very simple question. You can also give a try. See, the equation will be this way. What equation you will be using is log of K2 upon log of K1. K2 is higher rate constant. Like at a higher temperature, K1 is rate constant at a lower temperature. Log of K2. EA upon what? EA, activation energy, upon 2.303 into R into 1 upon T1 minus 1 upon T2. What would be this? Like 1 upon T1. T1 is lower temperature and T2 is higher. Right? Obviously, no. If this is like many students get confused that sometimes they will write T2 minus T1. If this is the case, this value will become negative, no? And rate constant cannot be negative. Understand this. So if you are getting confused, this should be always remember T1 upon T2. T1 is lower, right? So we'll use this. So log of K2. What they are saying is the rate becomes double when the temperature is raised from this. Let's say K1 is X, then what will be a K2? 2 times X, right? Means this is X, then this is at higher temperature, it becomes 2 times X. That is what it means. Means rate is becoming double. So EA is equal to what? So EA I am writing 2.303. R is what? 8.314. And what is this? This is 1 upon 298, right? 298 minus 1 upon 308. So this and this will get cancelled. What do we write is log of 2 is equal to EA upon 2.303 into 8.314, and this will be 298 multiplied by 308, and 308 minus 298. Right? What is log of 2? Log of 2 is 0.3010, which is equal to EA upon 2.303, 8.314, 298 and 308, and into 10, no? On top it will be a 10. This difference will be 10. Therefore EA will be equal to 0.3010, 2.303, 8.314 multiplied by 298 multiplied by 308 divided by 10. So activation energy final value comes to joules per mole. So in kilojoules it could be written as 52.903 kilojoules per mole. Right? Kilo means what? How do we write this? The same value could be written as what? 10 raised to 3 joules per mole. What is this 10 raised to 3 stands for? Kilo, no? 52.903, and instead of 10 raised to 3 I write this K, joules per mole. So this is the answer which you are getting, activation energy. Okay, here is a question, nice question. A rate constant K of a reaction varies with temperature T according to the equation. This is the equation. Okay, log of K is equal to log of A minus EA upon 2.303 R 1 by T, where EA is the activation energy. When a graph is plotted of log of K versus 1 by T, a straight line with a slope of minus 4250 Kelvin is obtained. Calculate the activation energy. You can give a try to this question. See, what we have to do is, we have to we have to relate this equation with the equation of straight line. What is the equation given? Equation given is log of K is equal to log of A minus A upon 2.303 R into 1 by T, right? So this is my y-axis, this is my mx, and this is C is the intercept. See, whenever you plot this equation, whenever you solve this equation, it is this way. This is log of K axis, this is 1 by T, and the graph is this way. So slope for this, what is the slope for this? Slope, see, EA is a constant, slope is always constant, no? We usually write M is a constant, right? So among this, EA is a constant, R is a gas constant, 2.30 is the value. So together, this is a slope. So therefore, what we can write is that minus EA upon 2.303 R equals to what? They have given, no, the slope of the straight line with the slope is equal to this, equals to this, minus 4250. Right? Therefore, EA you need to solve for this. I'll write over here. I'll write over here. Therefore, if I rearrange this, EA is equal to what? That minus and minus will go. So 4250, 2.303 R. R is what? 8.314 joules per Kelvin per mole. So final activation energy answer would be 81375.35 joules per mole. Now kilojoules, if it is asked in kilojoules, you can write in kilojoules. Therefore, EA is equal to 81.37 kilojoules per mole. This question, for a reaction, activation energy EA is equal to 0. They have given, and the rate constant at 200 Kelvin is 1.6 into 10 raised to 6 per second. The rate constant at 400 Kelvin. You are told to find a rate constant at higher temperature, 400 Kelvin. So what is the equation we use? When two temperatures are given, log of K2 upon log of K1 EA upon 2.303 R 1 upon T1 minus 1 upon T2. So over here, log of K2, I need to find the K2 for this. K1 is given to be how much? K1 is given to be 1.6 into 10 raised to 6. Now what is EA given? EA given to be 0, and I'll write this 2.303 into R. R is 8.314. And what is the temperature? Earlier it is 200 minus 1 by 400. So this, since there is a 0, activation energy is 0, what I can write is that log of K2 upon 1.6 into 10 raised to 6 to be is equal to 0. Like whole of this term will become equal to 0. So if I take anti-log on both the sides, anti-log of, because I need to get rid of this log, no? That's why I'm taking anti-log. So anti-log of log of K2 upon 1.6 into 10 raised to 6 is equal to anti-log of 0. So anti-log and log cancels. What remains is K2 1.6 into 10 raised to 6. 10 raised to anti-log of 0 is what? 10 raised to 0. Like anti-log of 1 will be what? 10 raised to 1. Anti-log of 2 will be what? 10 raised to 2. I always remember this. So anti-log of 0 will be what? 10 raised to 0 means K2 is equal to 1.6 into 10 raised to 6. Anything raised to 0 is what? 1. Therefore, new rate constant at 1.6 is 10 raised to 6, same as a K1. So we have to understand that when activation energy is 0, there won't be any effect of temperature on a rate constant. Means rate of reaction is independent of the temperature. Okay, we'll stop this class over here.